Manufacturing engineering at Technical University of Cluj-Napoca nowadays it's a well-known brand. It combines a strong manufacturing engineering experience with modern technologies and digital manufacturing methods. TCM Cluj adapted its curriculum and methods to the new reality from the modern companies. We aim to provide appropriate training to our students in computer-aided design, product design methods, CNC machining, digital manufacturing and 3D printing. Everything we do at manufacturing engineering is fully computer assisted. More and more engineers are required by the companies. Engineering is the engine of the society. We are surrounded by automated technical products, vehicles with automated gearboxes, automated central heating, and plenty of domestic appliances. So it is normal that the engineering jobs are well seen and highly appreciated.
Suntem într-o perioadă în care absolvenții de liceu și industria în general se reorientează către ceea ce înseamnă inginerie industrială, inginerie mecanică, pentru că, iată, datorită acestor noi tehnologii și acestor noi direcții, printre care și cea a fabricației aditive, cei care sunt implicați în acest proces pot observa foarte repede care sunt rezultatele muncii lor.
We have more and more applicants to study engineering. We never had so many incoming students as we had last summer. Besides 530 students financed by the Romanian government, our faculty has more than 200 students paying taxes. When the students are willing to pay taxes from their pocket to cover the fees for the studies, I am sure they know what they are doing. The machine building faculty offers the knowledge and experience of the teaching staff who work in Western universities and companies. Our professors brought the engineering experience from the West. They adapted the teaching methods to the reality and possibilities from Romania, and we provide training for our students based mainly on projects work. We try to teach our students how to solve problems instead of asking them to reproduce the theory by heart. The equipment from the laboratories is also very important. At Manufacturing Engineering Cluj, we have modern CNC machineries. We have 3D printing equipment, competitive and comparable to the most advanced equipment from the EU universities. Our students have the opportunity to work with the hands-on, using top-level equipment available at TCM Cluj. These very expensive equipment were purchased from some research projects developed by our academic staff. The main technologies taught at TCM Cluj are, first of all, additive manufacturing technologies such as selective laser melting and selective laser sintering, which are capable to produce directly complex physical parts using powder materials such as plastic, metal and ceramic powder. Using our selective laser melting machine, we could print directly a complex metal part made out of stainless steel or tool steel or titanium powder without being necessary any tooling. And the part has good mechanical properties, similar with the parts made out of laminated steel using subtractive technologies.
Well, for me, additive manufacturing, it's kind of a way getting back to how we used to make things. When you think of making a bowl out of clay, we used to add material and build it up gradually. And because we used our hands, it gave us lots of flexibility. Once we went over to using machine tools and we're removing material, it actually makes it less flexible, more wasteful. But now we've gone back to additive, so we're kind of almost going back to our history. And because of that, I think we're rediscovering some of the kind of ancient craft that we used to have. So although it's a very modern technology, it's actually making use of quite traditional ancient heritage.
Fabricația aditivă vine ca parte a celei de-a patra revoluții industriale și prin aceasta, în mod evident, reprezintă o parte din viitorul tehnologiei.
I consider additive manufacturing as the really next generation of manufacturing process that will come to every house, reduce the cost, create complex design of whatever you want at any time.
Additive manufacturing is a way of producing things without mold or dye, so you are very free in designing the shape. That means you can do one-offs. You don't need to produce a big series.
According to data, additive manufacturing will reach every industry very, very soon, which means that in every plant, every small workshop, people will have a printer and will be able to do a lot of things, from prototyping to production. And I'm just talking about the industry, even not the mass market.
Prin însăși natura acestor tehnologii, ele sunt captivante pentru tânăra generație, astfel încât, pe de o parte, cursuri care au ca subiect fabricația aditivă devin foarte importante pentru noi ca universitate și pentru studenții noștri și, pe de altă parte, din mediul industrial, companiile vin cu presiune pentru a răspunde unor cerințe ale clienților care se concentrează pe ceea ce înseamnă personalizare.
Manufacturing engineer in Cluj was a pioneer in Romania in the additive manufacturing field. 22 years ago, we started 3D printing at TCM Cluj with the support from the Romanian government. We purchased the first additive manufacturing equipment in Romania, and since then, we have got more and more experience in modern technologies. Now we cooperate very well with other top-level research laboratories from Europe. Now we are able to write successful national and European projects.
I think the most valuable aspects of Technical University of Cluj are, number one, the people. I always think people are the most valuable asset. Number two is the facilities, which are actually are world class. And number three, I'd say it's that sort of almost entrepreneurial spirit, prepared to have a go at doing some new ways of working, new ways of thinking. And when you get those three together, it's a very powerful combination.
I consider my collaboration with the Technical University of Cluj-Napoca extremely important, as much as professionally, as well as privately. I mean, we are doing very good work, very good job, much more than what was expected in the project initially, and everything in a very great and friendly atmosphere, so it's the key of success.
The University of Cluj is a very practical university. It's not just theoretical classroom knowledge, but you would see a lot of machines, so they really do what they teach.
The top-level research undertaken at TCM Cluj and the excellent partnership with European colleagues led to a successful AMaTUC conference organized here in Cluj-Napoca. From 93 accepted scientific articles, 45 came from abroad. The speakers came from 14 different countries, so the AMaTUC conference in Cluj was really international. We cooperate and have good partnerships not only with countries from East Europe, but also with well-known universities from Germany, England, and other Western countries.
AMaTUC project started with a previous collaboration between the Technical University of Cluj-Napoca, Loughborough University and Intelligentsia Consultants in another project, and we decided to develop a new opportunity together because it was a very successful previous project, and here comes AMaTUC.
AMaTUC stands for Additive Manufacturing at Technical University of Cluj. AMaTUC is a project coordinated by TCM Cluj and has experienced partners from Loughborough University, England, from University of Applied Sciences in Aachen, Germany, and from Intelligentsia, Luxembourg. This project was obtained by TUCN within a tough international competition. It is not like the special funds provided by the EU for Romania.
It was not knowledge from the West brought to the East, but they had their knowledge, we had another knowledge, and we really could work together. So we could build the cooperation on a basic knowledge which was already installed here. For example, in some aspects, they did even more than we did. They already worked on titanium, which we didn't do. And so it is a real cooperation.
So we've had joint projects going back quite a long time, and always, I guess from my aspect, I've been bringing along some design expertise, and the expertise here has been very much in the manufacturing, production, materials as well, and that complements what I've been doing with my team at Loughborough. And again, the new projects that we're looking to develop going into the future are once again trying to work on that partnership. And what's really exciting is now we're bringing in partners from other parts of Europe and indeed other parts of the world, and really forming a sort of truly multinational interdisciplinary project team, which is very exciting.
DCOMI is a New Horizon 2020 project. It is coordinated by Professor Campbell from Loughborough University, and TCM Cluj is an important partner at this new European project. The aim here is to design and produce a new type of 3D printer which should be capable to produce parts made out of composite materials by adding curved layers. This is the significant novelty of this new DCOMI project, which started recently and will run for the next 4 years.
I've been collaborating with University of Cluj-Napoca now going back, I think it's 20 years, and I've found they've always been very open to new ideas. They've been very open to developing new partnerships, and also they've been building a team of expertise, not just in one area, but by bringing people from different areas together. And that gives you the possibility, along with, I'm from a kind of design department at Loughborough University, and with the manufacturing department here, when we come together, we can tackle virtually any aspect of mechanical or manufacturing engineering.
TCM Cluj is also successful within the national project competition. For example, we have now 3 ongoing bridge projects with a budget of roughly 100,000 euros each. I am the coordinator of one bridge project focused on medical applications of selective laser melting in order to produce dental implants made out of titanium powder. Other bridge project is focused on water jet machining, and the third one is on producing complex parts from composite materials. All these national projects are doing a technological transfer from the research laboratories to one industrial partner who tries to implement these new emerging technologies. Cluj is well known for many famous IT companies located here who developed different software applications. They are important, but most of them are abstract. Here is one opportunity for TCM Cluj to develop specific engineering applications, to design and produce tools for end users so that the software applications get more interesting. And finally, special mechanical devices should do the practical job. The amazing thing is how mechanical engineering puts at work the software applications to do practical things. This is what we do at TCM Cluj. In this way, our students could be integrated into the labor market within the top-level companies, such as Daimler-Mercedes, where an automated gearbox for Mercedes car with 7 gears is assembled one after another in 18 seconds. Even if it's got almost 600 components, from the assembly line, one gearbox is ready after 18 seconds. Our students are well prepared for such a top-level engineering job. Besides the international cooperation with European universities, we cooperate very well also with the faculties from the Romanian universities, from Bucharest, Brașov, Iași, Sibiu, etc. Mainly within the manufacturing engineering field, we cooperate a lot, we have joint projects, and now at TCM Cluj was held the national meeting of the deans from the consortium of the mechanical and industrial engineering faculties from Romania. This is also a recognition of the experience of TCM Cluj to do here exchange of ideas and methodologies on how to improve our engineering education methods within the Romanian universities. The evaluation of this PhD thesis was made by an international commission, Professor Campbell from England, who is an expert on additive manufacturing and the editor of a famous scientific journal called the Rapid Prototyping Journal, which has a high impact factor. Professor Andreas Gebhardt, who is the Dean of the Mechanical and Mechatronic Faculty from Aachen, Professor Gheorghe Oancea, Dean at Transylvania University of Brașov, and Professor Peter Berce from Technical University of Cluj.
Planurile de învățământ pentru programul de studii Tehnologia Construcțiilor de Mașini au niște valori fundamentale care se regăsesc la toate universitățile din țară. Sigur că fiecare dintre universități are și o parte specifică și trebuie să recunoaștem că la Cluj de peste 20 de ani a existat o implicare foarte puternică în zona fabricației aditive.
Facultatea din Cluj de construcții de mașini are foarte bune colaborări cu Facultatea din Brașov, Inginerie Tehnologică și Management Industrial, cu Facultatea din București, din Iași și așa mai departe. Noi colaborăm atât în zona de cercetare, cât și în ultima perioadă în zona didactică.
TCM Cluj provides proper teaching and training on computer-aided manufacturing. The CNC turning equipment has 2 axes numerically controlled to machine rotational parts. We purchased this equipment from a project we had with a company from South Korea. We also have CNC machining centers with 4 and 5 axes simultaneously controlled, and those types of CNC equipment are widely used within the Romanian companies, so our students are well prepared. Some of this CNC equipment were purchased from the budget of the faculty, and some others were obtained from some companies such as Göring. Göring gave us 2 CNC machining centers to support us in providing a better practical training to our students. More than 3/4 of the engineers who work at Göring graduated at TCM Cluj. If companies want to get good engineers, they should help us to train them better. Innovative technologies such as EDM, electrical discharge machining, are useful in many cases to sort out complex engineering tasks. For example, we use the EDM wire cutting machine to remove the SLM parts from the base platform. Our students are so enthusiastic when they see with the hands-on how the thin brass wire could cut accurately into thick hard metals. Each of these non-conventional technologies has a specific way to remove the metal. If the EDM wire cutting is based on removing the metal by melting, using the thermal energy produced by the electrical sparks in between the brass wire and the metal part, the water jet machining is based on mechanical erosion to remove material from the workpiece. The water pressure is huge at the water jet machining. roughly 3,500 bars water pressure, which comes out through a thin nozzle, which could be moved numerically controlled to cut the two-dimensional profiles. When cutting hard materials, such as steel, we add ceramic grains into the pressurized water. Our students like to see how we could cut thick block of metals, up to 60 millimeters thickness, using just water jet machining. Metal forming technologies are also widely used, mainly within the automotive companies. We teach our students which are the main metal forming processes, how to design necessary molds and dies, and how to figure out different problems which might occur. For example, when the sheet metal is broken, how to determine the suitable formulas for different elastic and plastic deformations. 3D printing and additive manufacturing techniques are the top-level manufacturing methods, which attract students at TCM Cluj, coming even from far distances from Romania. Not only for 3D printing, but also for the strong experience available at TCM Cluj, where manufacturing engineering is taught in 3 languages: Romanian, English and German. These students attending the German classes take benefits from the student scholarships given by the University of Stuttgart for our students to study 1 semester in Germany at Stuttgart University. That is due to a long and good cooperation with the EU universities and with big multinational companies which have branches in Romania, such as Daimler, Bosch, Bielomatic, Göring, Eckerle and so on. Up to now, the usual migration of the labor force was from Romania to the West, Germany or England. Usually people go to study abroad and get a doctorate degree in Western countries. There are some special cases when some people who graduated engineering in Germany, both bachelor and master, and now they come to do a PhD at TCM Cluj in English and get the doctorate from the Technical University of Cluj-Napoca. Such an example is Miss Julia Kessler, who did an excellent research on selective laser melting.
My name is Julia Kessler. I'm from the University of Applied Sciences in Aachen. It's in Germany. And I'm a PhD student. Actually, I graduated to a Doctor of Engineering, and I did my PhD study here for 3 years, and in cooperation with the Technical University of Cluj-Napoca. And my co-fathers were Professor Nico Balk and Professor Andreas Gebhardt from the University of Applied Science in Aachen. Have to find design rules to integrate these fine lattice structures made by selective laser melting into components from the industry. Therefore, I made a lot of practical experience or practical experimental setups. I had a basic and the main research where I worked with a lot of specimens. I made in total, I think, 640 probes to evaluate and to find a guideline of how you can work and how you can integrate these structures into your components.
Julia Kessler obtained the Doctor of Engineering diploma with top-level distinction from Technical University of Cluj-Napoca. All these new modern directions implemented at TCM Cluj, such as 3D printing, digital manufacturing, are integrated within the new concept called Industry 4.0. We adapt the teaching and training methods to the trends of the industry with the overall aim to bring the manufacturing engineering into the future. I graduated 30 years ago manufacturing engineering here at TCM Cluj. My professors at that time gave us a proper training. So it is my duty and it is our duty as professors now to do our best and provide a proper and updating teaching for our students so that they should be well prepared for what the industry will be in 10 years' time. As a university, we should be a few steps ahead of the industry in order to prepare the engineers for the future.